everyone! In this video, I'm going to show you how to solve a system of equations by substitution. We're going to be looking at linear equations in this video, which is just a fancy math word. Linear means lines, so that's line equations. And we're going to be looking at two equations, so solving two equations at the same time. And just a quick recap, solving by graphing. The idea from solving by graphing is that if you've got two different equations of lines, you can graph those two lines and say they look like this. Then there's a point, so long as the lines have different slopes, then you'll always have one point where those two lines meet, and that point is your solution. So if this was at 4 and this was at 2, then your solution would be 4, 2. And sometimes the equations work out really nicely. You can graph them very easily, and you get nice integer coordinates like this. Obviously, this isn't a grid, but if you actually had grid paper, you could figure this out. But sometimes you're going to get equations that are going to give you like really ugly fractions, and you can't really solve them by graphing. Well, not accurately anyway. You could get maybe a decimal approximation or something. But like if let's say this was your box on your grid paper, and this was at 3, and this was at 4, and this was at 2, and this was at 3, and your lines sort of crossed, somewhere in the middle of the box. Like, what's that? Is that like 3.6 or something? Is that like 2.4? I don't know. Like you can never know. You can sort of guess and estimate, but you'll never get the exact value unless it happens to be an integer point by graphing. But substitution will always give you the exact solution every time, which is kind of cool. And it's also really useful for all types of equations, not just linear equations. At higher levels, once you sort of master the skill, you can even solve things that you don't even know how to graph. It's a very powerful skill. So let's just jump right in. We're going to do one. We'll start with one that's in y equals mx plus b form already. So y equals 2x minus 10. And let's make our second equation y equals 1/2 x minus 1. Okay, so these ones are set up. You could solve this by graphing, and I encourage you to try if you like. But because of this half in front of this slope, maybe we will or maybe we won't actually get an integer solution from this. Although I guess really a fractional slope is no guarantee anyway. You could get nice integer slopes and still get an ugly fraction of a solution. But anyway, you can try graphing this if you like, but I'm going to show you guys how to solve by substitution. Now the key idea is that at this point where your two lines intersect, that point of intersection, your x and your y values are the same. So that means that these two x values have to be the same thing, and your two y values have to be the same thing. Now, we know that y is 2x minus 10. But the second equation tells us that y is also, at the point of intersection, that same y value will give us 1/2 x minus 1. Which means that we have y and y can be set equal to each other. So really what we're going to do is we're going to say we want y equal to y. And those are the two y's from our two different equations. Now, normally you wouldn't write this, of course. But what this means is our left-hand side we're going to set to be 2x minus 10. And this is equal to our other y. And the other y is equal to 1/2 x minus 1. And that's because the point of intersection is the point where the y value is the same in both of your lines, right? The point where both your y values are the same is your point of intersection, is your solution. Well now, like this is, middle school algebra. Let's solve this for x. This is slightly tricky because we've got a fraction. Fractions are kind of ugly. So there's a nice little trick we can do to get rid of our fraction. We can take our entire equation and multiply by our denominator, which is 2. So I'm just going to multiply everything by 2. I call this nuking the fractions. So 2 times 2 is 4. 10 times 2 is 20. 1/2 times 2 is 1, so that's just x. And -1 times 2 is -2. So by multiplying by 2, that gets rid of our fraction, which is a nice sort of algebra skill to have. Makes it a lot easier to solve things. So I'm going to bring this to the left-hand side because that'll make my x's positive. So we are going to minus x to both sides, and we will add 20 to both sides while we're at it. So on our left-hand side, we have 3 x's, and on our right-hand side, we have -2 plus 20 is positive 18. And now we're going to divide by our coefficient. So divide top and bottom by 3, and we get x equals 6. Okay, so that's half of our solution. We have found the x value of our solution. But we still don't know our y value. So what we're going to do is we're going to take that x value and we are going to substitute it into one of our equations. And I'm going to choose the equation that doesn't have a fraction, just because why deal with fractions if you don't have to, right? So in particular, not just there, we're going to take that x value of 6 and substitute it in for x, because x is 6, which means that the x in this equation also has to be 6. So y equals 2x minus 10. Y equals 2x minus 10. When we substitute x equals 6, we get y equals 2 times 6 minus 10. And this we just multiply out. 2 times 6 is 12 minus 10. Hopefully you don't need a calculator for 12 minus 10 to get 2. So there is the y value of your solution. Oh, conveniently, we actually got an integer solution. So our solution is x comma y, 6 comma 2. Okay, so there you go. All right, so that one worked out nicely. This one actually does work out nicely by graphing, but this next one that we're going to do does not work out nicely to graph. If you try to solve by graphing, you'll get weird decimal numbers or fractions that you can't get the exact value from. So let's try another one. And this one's not going to be in slope-intercept form either. We're going to do in, this is sometimes called XY Intercept form, because you can get your x and your y intercept fairly easily from this. Just as an aside, it's not part of this. But if you wanted to get your y-intercept is when x equals 0. So if you sub 0 in for here, you get 4y equals 12, which means your y-intercept is 3. And your y-intercept is going to be when your x-intercept is going to be when y is 0. So if y is 0, this whole thing disappears. So you get 3x equals 12, which means that x is 4. So this is a really cool form for finding your x and y intercepts. Anyway, you can graph this equation really easily, but it turns out that the intersection is not going to be nearly so nice. So we aren't going to solve this by graphing. So how are we going to solve this? Well, we'd like to do substitution, but the problem is we don't have y anywhere. We don't have x anywhere on its own. And so the key idea of how we could solve this first one here was we had y equals this stuff and y equals this stuff. So then we could substitute y equals y. So we could replace this green y with the 2x minus 10. So we're going to have to do a little bit of work to get there. Let's isolate y in our yellow equation. So what we're going to do is we're going to take this equation and we're going to isolate y. So first thing we're going to do is we're going to get rid of our x term. So that gives us that 4y equals negative 3x plus 12. And then we're going to divide everything by 4. By the way, I chose this equation because looking ahead, I noticed that 12 divided by 4 would work out nicely, but 5 divided by 2 is going to give me a fraction. So that's why I chose this yellow equation. But so if you can look ahead and see that that's great. If not, you'll just end up with a little bit more fraction-y stuff in your answer. Regardless, we've got 3/4 here for x, so we still have a fraction. Okay, but anyway, y is negative 3/4 x plus 3. Now, we don't have y isolated in this equation, but that's okay. We can take this whole binomial and substitute it in for y, because at the point of intersection, this y and this y are the same thing, and our yellow y is negative 3/4 x plus 3, which means that our pale green y also has to be negative 3/4 x plus 3. So we are going to take our second equation, 2, but instead of y, we will substitute negative 3/4 x plus 3, right? This substitution here. And then we're going to write out the rest of that pale green equation, minus 6x equals 5. Okay, so now we've got, I think this is a grade 9 algebra question, right? We need to distribute and then, solve and so on. So let's multiply this across by 2 and see what we get. I'm going to do a little bit of math trick, by the way. The 2 and the 4 I can reduce in this step. So instead of doing 2 times 3 and getting 6, I'm going to go right to 3 over 2, because the 2 can reduce your denominator by 2. And if you didn't follow that, what I've done is I basically turned negative 6 over 4 and I've reduced it to -3/2 in one step. So if you can see that, that's great. Saves you a little bit of work. And then this pale green stuff's just chilling. -6x equals 5. I've got a fraction again. And working with fractions, I find students make a lot of mistakes, and myself as well. I have to make mistakes with fractions. So same trick we did getting rid of the fraction in the last, I shouldn't say trick, the same skill we used to get rid of the fraction in the last question. Let's do the same thing here. So the over 2 times 2 reduces, or it cancels each other. So it's just -3. 6 times 2 is usually 12. 6 times 2 is usually 12. Little math joke there. And then 5 times 2 is 10. Okay, so now let's, well, we've already got our x's over here. So let's collect our x's. We've got -15 of them. And the opposite of a +12 is a -12. So 10 minus 12 is -2. And -2 we're going to reduce by -15. Negative over negative cancels. So our x value is 2/15. Now, if you can imagine graphing this, good luck noticing that it's exactly 2/15 of the way across a box. You need to be like a computer program to see that, right? Like it's just not possible. Which is the nice thing about substitution. We have the exact value is exactly 2/15. So now we're going to take that value and we will sub it into our equation. We use the pale green equation to solve. So generally it's a good idea to sub into the other equation. So we're going to sub into our yellow equation up here. So x is 2/15. So I guess technically we're going to substitute it in here for x. So 4y plus 3x. 4y plus 3x equals 12. Okay, and then we're going to substitute in for x. So our x is going to become 2/15. And everything else is just going to stay the same in this line because that's our substitution. So 4y plus 3 times 2/15 is 12. Again, I can reduce. 15 is 3 times 5. So the 3 can reduce the 3 underneath. So this can become 2/5. And if you don't see that, you can do like the long way. Would be 3 times 2 is 6. 6 divided by 15 reduces, right, divide by 3 to your 2/5. Okay, so either way you'll get your 2/5 in one step or two steps, whatever makes sense for you. And again, I've got fifths. I don't want to deal with fifths. I don't want to subtract fifths. I mean, subtracting fifths isn't so bad, but I really, really like this algebra skill of getting rid of fractions. It's a really useful skill to have, so that's why I'm showing it over and over again, because you really want to have that skill in your toolbox going forward. So 4 times 5 is 20, 2/5 times 5, the fifths and the 5 cancel, and 12 times 5 is 60. And now this I can do in my head. 60 minus 2 is 58, and then the 20 I'm going to reduce by. So y equals 50 over 28, which is 29 over 10. So there you have it. Your solution is, let's call it the point of intersection this time because they mean the same thing. So the point of intersection, which is another way of asking for the solution, is 2/15, 29/10. And again, good luck seeing 29/10 on a graph accurately, right? Like you can't. This is one of the superpowers of substitution, is you always get the exact solution. And actually in 20-1, you're going to end up with radical, which means like square root solutions, and you'll be able to get those exactly as well. And you can't see a radical on a graph, even if you are a computer. Okay, so that's basically the lesson. But I wanted to show you guys one more way you can sort of make substitution a bit easier for yourself. This is one that's going to look ugly, but it's actually a lot easier than the question we just did. 3y minus 5x equals 11. And I'll leave a bit of space. 5y plus 5x equals -7. So again, our variables aren't isolated for y or x, but if you notice, there's 5x in the pink equation, and there's 5x in the orange equation. So I can actually isolate 5x really easily in either of these equations. I've written the pink equation first. So actually, no, this one's probably easier to isolate. So to isolate 5x down here, all I need to do is do minus 5y on both sides, right? So my y's cancel on the left. So 5x equals negative 5y minus 7. So 5x equals this, which means that this 5x also has to equal that. Kind of cool, eh? So like you don't need to necessarily isolate the variable. If you notice your coefficients are exactly the same, you can save yourself some steps. So if I then do the substitution, I'm going to get 3y minus, now notice the minus is still there, the minus is important, but this whole 5x I can now replace. That whole 5x is negative 5y minus 7, because this 5x is negative 5y minus 7. And this equals 11. That's the rest of our equation. Okay, so we need to be careful here distributing our negative sign. I'm going to do that in its own line just because it's so easy to make a negative sign mistake, right? So distribute your negative sign. So that becomes negative and negative makes positive, and negative makes positive. And I will subtract 7 and collect my y's. So 3y and 5y makes 8y, and 11 minus 7 is 4, last I checked. And then divide by 8, and 4 divided by 8 is a half. So y is a half, and let's substitute that value of a half into our orange equation. So 5 times a half plus 5x equals negative 7. I don't want to multiply by a half. Multiplying by a half is going to give me a fraction. Why do that? Let's just multiply by 2 instead. Ha! So my half and my 2 cancel, leaving me with 5. 5 times 2 is 10. Negative 7 times 2 is negative 14. There we go. No fractions needed. Minus 5, minus 5. So 10x equals negative 19. So x is negative 19 over 10. So put these two pieces together, and your solution is negative 19 over 10, comma, a half. That is solving by substitution.